Hello, friends. Welcome to Learning Nails and Aesthetics. Today we're starting Chapter 6, page 153 in the Milady Foundations book. After completing this chapter, you will be able to explain chemistry and chemical safety, identify the basics of chemical structure, explain the difference between solutions, suspensions, and emulsions, describe the potential hydrogen and how the pH scale works, summarize neutralization and redox reactions, practice chemical safety, interpret safety data sheets. Explain chemistry and chemical safety. As a beauty professional, you will work with chemistry every day. Chemistry, along with chemicals and chemical changes, makes life on Earth possible. The daily functioning of our bodies is based on chemical reactions, and our very hair, skin, and nails are made of chemicals. Creams, lotions, masks, and makeup, whether they come from natural sources like plant extracts or from ingredients manufactured in a laboratory, are made from chemicals. The effect of cosmetics and beauty products are based on how the body reacts to chemicals. Beauty professionals must have a basic knowledge of chemistry to understand how different chemicals affect the hair, nails, or skin, and to be able to choose the correct products for each client's particular needs. Beauty professionals should study and have a thorough understanding of chemistry because without an understanding of basic chemistry, they will not be able to use professional products effectively and safely. Every product used in beauty and wellness services contains some type of chemical. Beauty professionals should be able to troubleshoot and solve potential common problems with chemical services. It is important to know and follow the procedures for handling chemicals used in the salon, spa, and barbershop by reading labels and following manufacturers' instructions to keep their clients and themselves safe. Identify the basics of chemical structure. Chemistry is the science that deals with the composition, structures, and properties of matter and how matter changes under different conditions. So then, what is matter? Matter is a substance that occupies space and has a mass, weight. All matter has physical and chemical properties and exists in the form of a solid, liquid, or gas. Since matter is made from chemicals, everything made out of matter is a chemical. Matter has physical properties that can touch, taste, smell, or see. In fact, everything you touch and everything you can see, with the exception of light and electricity, is matter. All matter is made up of chemicals. You can see visible light and light created by electrical sparks. However, these are not made of matter. Light and electricity are forms of energy. Energy is not matter. Everything known to exist in the universe is made of either matter or energy. There are no exceptions to this rule. Energy does not occupy space or have mass. Energy is discussed further in Chapter 7, Electricity and Electrical Safety. Elements. An element is the simplest form of chemical matter and contains only one type of atom. It cannot be broken down into a simpler substance without loss of identity. There are 118 elements known to science today. 98 occur naturally on Earth. The remaining elements, known as synthetic elements, are produced artificially or through synthesis. All matter in the known universe is made up of elements that have their own distinct physical and chemical properties. Each element is identified by a letter symbol, such as O for oxygen, C for carbon, or H for hydrogen. Symbols of all the elements can be found on the periodic table of elements in chemistry textbooks or by searching the internet. Did you know the use of the word chemical to describe something does not mean it is dangerous or harmful? Water and air, and even our body, are completely composed of chemicals. The vast majority of chemicals with which you come in contact every day are safe and harmless. Similarly, the word organic simply means that a substance contains the element carbon. although the term is often used to mean safe or natural because of its association with living things. Not all organic substances are natural, healthy, or safe. Atoms are the basic unit of matter, with a nucleus at the center surrounded by negatively charged electrons that move around the nucleus in orbits. The nucleus consists of protons, which is a subatomic particle with a positive charge, and neutrons, which is subatomic particles with no charge. And it is the number of protons that determines the element. Atoms cannot be divided into simpler substances by ordinary chemical means. Figure 6.2 shows the atomic structure of carbon, with 6 protons and 6 neutrons at the nucleus and 6 electrons in the orbit. Molecules. Just as words are made by combining letters, molecules are made by combining atoms. A molecule is a chemical combination of 2 or more atoms in definite fixed proportions. For example, water is made from hydrogen atoms and oxygen atoms. Carbon dioxide is made from carbon atoms and oxygen atoms. Atmospheric oxygen and other chemical substances, such as nitrogen and water vapor, make up the air you breathe. Atmospheric oxygen is considered an elemental molecule, a molecule containing 2 or more atoms of the same element, in this case, oxygen. In definite fixed proportions, it is written as O2. Ozone is another elemental molecule made up of oxygen. Ozone is a major component of smog and can be very dangerous. It contains 3 atoms of the element oxygen and is written as O3. Compound molecules, also known as compounds, are chemical combinations of 2 or more atoms of different elements in definite fixed proportions. Sodium chloride, NaCl, common table salt, is an example of a compound. Figure 6.3, elemental molecules contain 2 or more atoms of the same element in fixed proportions. Figure 6.4, compound molecules contain 2 or more atoms of different elements in fixed proportions. Each sodium chloride molecule contains 1 atom of the element sodium, Na, and 1 atom of the element chlorine, Ci. Physical and chemical properties of matter can be changed in 2 different ways. Physical forces cause physical change, and chemical reactions cause chemical changes. A physical change is a change in the form or physical properties of a substance without a chemical reaction or the creation of a new substance. No chemical reactions are involved in physical change and no new chemicals are formed. Solid ice undergoes a physical change when it melts into water and then converts into steam when heat is applied. A physical change occurs when nail polish is applied to the nails and the solvent evaporates, forming a layer or film on the nail. A chemical change is a change in the chemical composition or makeup of a substance. This change is caused by chemical reactions that create new chemical substances, usually by combining or subtracting certain elements. Those new substances have different chemicals and physical properties. In fact, every substance has a unique property that allows us to identify it. As with the 2 types of changes, the 2 types of properties are physical and chemical as well. The creation of water through acid neutralization is a chemical change. Physical properties are characteristics that can be determined without a chemical reaction and do not involve a chemical change in the substance. Physical properties include color, soluble, odor, density, melting point, boiling point, hardness, and glossiness. Chemical properties are characteristics that can be determined only by a chemical reaction and involve a chemical change in the substance. Examples include the ability of iron to rust, wood to burn, or hair to change color through the use of hair color and hydrogen peroxide. Pure substances and physical mixtures. All matter can be classified as either a pure substance or a physical mixture. A pure substance is a chemical combination of matter in fixed proportions. Pure substances have unique properties. Water and salt are examples of pure substances, with atoms in a set proportion. 2 hydrogen atoms per oxygen atom, H2O, and 1 sodium atom per chlorine atom, NaCl, respectively. Most substances do not exist in a pure state. Air contains many substances, including nitrogen, carbon dioxide, and water vapor. This is an example of a physical mixture. A physical mixture is a physical combination of matter in any proportion. The properties of a physical mixture are the combined properties of the substances in the mixture. Salt water is a physical mixture of salt and water in any proportion. The properties of salt water are the properties contained in salt and in water. Salt water is salty and wet. Most of the products that beauty professionals use are physical mixtures. Check-in. Describe pure substances and physical mixtures. Give examples. Explain the differences between solutions, suspensions, and emulsions. To better serve their clients, beauty professionals should have an understanding of the chemical composition, preparation, and use of cosmetics that are intended for hair, skin, nails, and body in general. Most of the products a beauty professional uses are solutions, suspensions, and emulsions. Solutions, suspensions, and emulsions are all physical mixtures. The distinction between them depends on the type of substance, the size of the particles, and the solubility of the substances. Solubility. A solution is a stable, uniform mixture of 2 or more substances. The solute of the substance that is dissolved in a solution. The solvent is the substance that dissolves the solute and makes the solution. A solution is created when a solute is dissolved in a solvent. For example, when salt is dissolved in water, salt is the solute and water is the solvent. Water is known as the universal solvent because it has the ability to dissolve more substances than any other solvent. Activity. Evaporation experimentation. Put an ounce of clear hair styling spray into a cup. Cover it loosely with a paper towel and set it aside for a week. What happens when the liquid evaporates? What does the residue look like? Touch and feel the residue. In chemistry terms, what is the residue? All liquids are neither miscible or immiscible. Miscible liquids are mutually soluble. Just a moment, my eyes are really watering. I apologize. Everything's all blurry. Meaning that it can be mixed together to form solutions. Water and alcohol are examples of miscible liquids, as in a nail polish remover. When these substances are mixed together, they will stay mixed, forming a solution. Solutions contain small particles that are invisible to the naked eye. Solutions are usually transparent, although they may be colored. They do not separate when left still. Again, salt water is an example of a solution with a solid dissolved in a liquid. Water is the solvent that dissolves in the salt solute and holds it in solution. Immiscible liquids are not capable of being mixed together to form stable solutions. Water and oil are 2 examples. They can be mixed together but will separate when they are left setting still. When immiscible liquids are combined, they form suspensions. Suspensions are unstable physical mixtures of undissolved particles in a liquid. Compared with solutions, Suspensions contain a larger and fewer miscible particles. The particles are generally visible to the naked eye, but are not large enough to settle quickly to the bottom. Suspensions are not usually transparent and may be colored. They are unstable and separate over time, which is why some lotions and creams can separate in the bottle and need to be shaken before they are used. An example of a suspension is the glitter in nail polish, which can separate from the polish. Calamine lotion is another example. An emulsion is an unstable physical mixture of two or more immiscible substances that normally will not stay mixed, plus a special ingredient called an emulsifier. An emulsifier is an ingredient that brings two normally incompatible materials together and binds them into a uniform and fairly stable mixture. Emulsions are considered to be a special type of suspension because they can separate. However, the separation usually happens very slowly over a long period of time. An example of an emulsion is skin cream. A properly formulated emulsion stored under ideal conditions can be stable for up to 3 years. Since conditions are rarely ideal, all cosmetic emulsions should be used within 1 year of purchase. Always refer to the product's instructions and cautions for specific details. We are going to stop there for today. I will continue Chapter 6, Health and Safety, and Chemistry and Chemical Safety, in the next few videos. Please like, share, and subscribe. I hope this is helpful to you, and I appreciate you watching. Have a great day. Thanks. Bye.